Awesome. Awesome. Thank you, everyone. Am I audible first of all? Yeah, loud and clear. Awesome. Yeah, my name is Ankit, and first of all, I would like to thank all of you for taking out your time from your day. It really takes a lot, and I really appreciate that. I will try to give as much as value possible back to you, and yeah, let's get started. Um, Actually, before getting it started, let me just tell you, this is the first time I'm presenting in an in a conference like this. So please cut me some slack. Feedback is appreciated, but especially the negative feedback is really appreciated. But uh, yeah, moving on. So as Solomon mentioned, I am a senior Android engineer at Tangerine. Tangerine, if you don't know, we are the biggest online bank in Canada. We do have some openings. Please do check our career portal if you are looking for a change. I have over 10 years of experience building mobile apps. I started my career back in Objective C era. Swift was not even launched then, and I mid career I decided to move to Android. Decision I would never regret. Um, and I've seen both sides of the worlds. I've seen us build and scale both apps on Android and on iOS. So I really understand what it takes to build and scale platform apps on each platforms, and also the limitations on of of building on each platforms. Um, uh, so before getting started, I want to start off with this quote from this Chinese philosopher. It goes like, "The greatest joy is to learn, and the second greatest is to teach." Um, I really love doing this. Uh, so please, feedback is really appreciated. All right, so let's get started. Agenda for tonight. Uh, we are. I have a lot of things on here, so hopefully I'm will be able to cover all of it. We'll start off with the MAD ecosystem. By MAD I mean mobile application development, and you will see it's really chaotic. Um, then we're going to compare Android and iOS. Um, we will see how these are two platforms differ from each other. We will see what are the challenges right now in implementing a cross-platform solution. I will introduce the solution. I will explain how it works. I'll explain what is different about this platform, this technology. We'll do a case study on how it has evolved. We'll talk about what is shared. We'll talk about what is not shared, and then we'll talk about what are the limitations of this technology. What are the problems? We'll present a solution, and then we look at the future roadmap. And if time allows, I have a demo as well. All right. So first thing first, let's look at the broader landscape, a bird's eye view of how mobile apps are built these days. They are broadly classified into three categories: native, cross-platform, and hybrid. Natives, as you all know, are the OG of the game. You build the best apps on native. On iOS, you use Swift, Objective C. On Android, you use Java and Kotlin, and they give the best performance, the best developer experience in building mobile apps. Then we have cross-platform technologies. We have React Native, Flutter, and Xamarin. Um, and then lastly, we have some hybrid technologies. These hybrid technologies are mostly something running on top of a web view. So the three most popular hybrid technologies are Cordova, Ionic, and Capacitor. So if you notice on this slide, all the big names are behind this problem. Look at it. Meta is behind it. Google, Microsoft, Apple, right? Um, and to be honest, cross-platform technology. The problem with the cross-platform technology has not been solved yet, even after multiple attempts. Why? So in order to understand why, let's first compare iOS and Android. Um, let's look at the differences between these two platforms. So first thing first, Android runs on JVM. Uh, JVM is Java Virtual Machine. It runs anything which is a jar can basically run on a JVM. Android, so on iOS has a very very native technology to themselves. They build a technology where they convert the source code into low level machine code using a process called LLVM. When it comes to memory management, Android uses garbage collector. Uh, on iOS, we have automatic reference counting, ARC. It's a beautiful concept. If you don't know about it, read about it. It's a great concept, much better than garbage collector in my opinion. But that's up for discussion. Then on Android, like the practical use case, a context of of your application plays a really important role. Um, so if you have to communicate anything outside your Kotlin or Java code, you need a context. If you need to access the resources, you need a context. You need to access push notifications, you need a context. Locations, camera, you name it, you need a context. On iOS, we don't have a problem of context. There's no concept such as context. Everything is mostly a singleton, and you can just access a singleton from anywhere, which also brings to a problem of configuration changes. On Android, the configuration of your app can change. If you rotate the screen, if you rotate your device, suddenly your configuration changes, suddenly you've lost some data. You have to build for that. If you have you have an app which runs on a split screen, you try to drag and change the window of the app, your context will change, and you have to really build for that. On iOS, there is no concept of configuration change. Everything runs smoothly. There's no, we're not building. We build for process depth. That concept is true in both platforms, but there's no concept of configuration changes as such on iOS. That's not it. We have other differences. The permission model on both platforms is different. The way Android requests permission, manages permissions is very different than what iOS do. On iOS, you have, if you look at camera, you have, when you request for permission, you can access a fine-grained permission. On Android, you can still do it, but there are multiple layers when it comes to permission on Android. On Android, we use activity or fragment or sometimes both of them, and that's like a canvas where you build your mobile apps. On iOS, we only one concept of view controllers. We have another concept of child view controllers, but that's not similar to fragment. That's still different. The layout, how we build layout on each platform is different. On Android, we use XML. Modern day, we use Jetpack Compose. On iOS, they build their own solution where they have a storyboard. You drag and drop things. It's literally like working with Figma. It's really smooth to work with. And they also have a similar concept of Swift UI. They're very similar to Jetpack Compose. The life cycle events of each platform are different. On Android, it's a very complicated life cycle mechanism. Starting from, so there are various life cycle events on Android, and then there are various life cycle of the activity, and then there are life cycle events of the fragment. And if you are in a situation you're dealing with trying to really balance, you'll find yourself in a very tough spot. On iOS, life cycle is very straightforward. You have view did load, view will appear, view did appear, all that. It's a very straightforward concept of life cycle on iOS. The threading model between each platform is different. One uses a thread executor. They have Android uses handlers and loopers, and essentially there's a looper running on a main thread which is listening for the events coming out down to the main thread, and then it can also spin up a new thread from a thread pool. On iOS, we have a different concept. We have a concept of GCD, Great Central Dispatch. We have a concept of operational queues. Android doesn't have those concepts. Android has coroutines now. iOS doesn't have a concept like coroutines. Things like background processing. If you want to download a video in background, you have various ways on Android to do it. iOS is very strict about it, what it allows on background and what it doesn't allow in background. And it's relatively harder to build on iOS doing anything on background. It's really hard to hide things. Um, so it's clear these two platforms are inherently different, and there are good reasons behind it. Java, so in my opinion, Android was done as an open source software by developers who build for servlets, Hibernates, the old school developers which had huge architectural mindset, who wants to pass everything as a dependency and have a very loose coupled code. And they were also building a open source software which they knew where it's going to run. However, iOS was building for a very small subset of use case. They owned the hardware, so they could control how the apps would be built on each platform. So in my opinion, iOS is much easier to do than Android, um, and yeah, but Android is still really good because you learn a lot of other concepts which you take for granted on iOS. So, which brings me to what are the challenges of sharing code between each platform. I'm not going to name any technology per se, but I'm going to list down the broader challenges. The first and foremost is the performance issue. Um, if you have a React Native or Flutter app and you're trying to crop an image, you're trying to upload a video in background while navigating in an app, or you're trying to apply some filter on an image, you'll see the lag. Even if you build it for perfection, you spend a lot of time mastering it, you will still see the lag. um, uh, there are limitations to access native features. So if you want to record a video in a React Native or a Flutter app, I'm not saying it's impossible to do, but it's fairly complicated to do. And then you also get into this device specific issues, like something is not working on Samsung on a React Native project, which is very, it's very tightly coupled by the framework itself. The UI and UX between each platform is different. So a very good example of this is WhatsApp. If you have used WhatsApp on an iOS device versus on an Android device, you would see the entire applications are different. And the reason, because Android user think differently and iOS users thinks differently. There's a physical back button on an Android phone, so you have to build for that. You sharing, like if you use a cross platform technology, you would see that this doesn't feel native, the app bar doesn't feel native, the button click doesn't feel native, or the transition doesn't feel native. You're limited by the framework. A good example of this is the day Apple released dark mode, it took a while for all the React Native apps to adopt that, because it was not supported from the framework level itself. So you have to wait for Facebook to first release something so that you can use the dark mode. Similar with dynamic fonts or anything of this sort, you are always limited by a framework and always on their mercy on when they're going to do it, and then you can take advantage of that. Debugging and maintaining a cross-platform app is really difficult. Um, if you have, I'm not talking about a normal workflow where you just make an API call, get some data and show it. But let's say you have a local database, you have multiple threads, you are writing to that database from multiple spots. It's really hard to debug this on a cross-platform app. And the application size, because you're importing a new framework, the application size is relatively really big than as compared to a native app. Introducing Kotlin Multiplatform. How many of us have heard about Kotlin Multiplatform? All of them. That's why you're here. So what is Kotlin Multiplatform? Kotlin Multiplatform is a technology which aims to streamline the development process for the cross-platform app development. Uh, so basically, this technology is not mandating you share everything. No, that's not the idea here. The technology is built for you to share just enough that will that is that's going to solve your use case, but you still have a flexibility to take advantage of all the native features which each platform has to offer. So Kotlin multi-platform really respects the boundaries very well. It it mostly runs on so the primary use case right now of Kotlin multi-platform is on mobile. You can share code between iOS and Android. uh, I'll keep speaking, I guess. The second big use case, which is really very big in my opinion, is sharing libraries. Right now, most libraries are written in C++. If you're writing a cross-platform library, you are writing it in C++. If any one of you has worked in a FANG, you would know that there's a big library which is written in C++, which you're supposed to use. And it's written in C++ because it's been shared between iOS and Android. And then the third use case of Kotlin multi-platform right now, the biggest use case is building for desktop apps. So if you are like Netflix, or if you have Crave, you're hot. If you have a lot of platform to support. So like, think of like Netflix. Netflix has to support a web app. They have to support native app. They have to support a, a desktop app on iOS, on Apple, on Windows, and then who knows, Chromecast or Chromebooks. Um, so they have a lot of use cases, and they're writing same code in lot of different places. If they can share their core and just have different implementations for platform specific code, it will save them a lot of time and resources. So how does Kotlin multi-platform exactly work? Um, so Kotlin multi-platform is just compiling Kotlin into the native equivalent. So for example, on iOS, Kotlin is compiled. So I want to get this right. Kotlin compiles and creates Objective C headers, uh, so that the Swift code can call those Objective C headers. On Android, it's business as usual. It's Kotlin, it's Java. You just compile down into JVM bytecode and you run. And you can technically you can also compile down Kotlin into JavaScript. Now, this is not ready for production yet, but it is very promising. It is it is it'll be great to share everything, to just write a code and share in all the different platforms. Um, so why is it different? Why is it different from all other cross-platform solutions we have seen so far? First of all, because of its approach. Kotlin multi-platform the idea is not to share everything. The idea is to share the things which are meant to be shared. The business logics, the core, the crux of the code, that needs to be shared. If you have a logic of, you go to this screen, you call 3 different APIs in parallel, and then you call this API in sequence, that's the business logic which is worth sharing, not what happens to the data when the network responds. So Kotlin multi-platform really focus on the right thing, and it allows to have the platform specific implementation. So if you cannot do something on this, you are always having a native fallback to go to. Is this the only technology who try to do this? No. Flutter has done something similar, but Dart is, in my honest opinion, a pain to work with. Um, uh, I love Kotlin. This is the language I choose to write code, and for good reasons, right? It is really a modern language, easy to write, easy to understand. You don't have to remember a lot of things. It's easy to reason about. It has lots and lots of utility functions, and the best part, it compiles down into the native platform specific code, and the support, like the Kotlin multi-platform technology is supported by JetBrains. All of us Android developers, they know this name JetBrains, they know who they are, and then we have all seen the history of the company. And Kotlin multi-platform is one of their most ambitious projects. They are pushing really hard for it, um, and all the big guns, they've convinced all the big guns to follow them. So here on the right, I have an image. So this image is taken from clean architecture. If you know what that is, um, if you don't, there's a very famous book from Uncle Bob about clean architecture. And the reason I added this image is just to demonstrate what are we sharing. We are not sharing domain, application, and persistence layer. All we are sharing, sorry, we are sharing application, domain, and persistence layer. What we are not sharing is the presentation layer. The presentation layer can live with the platform. There's no problem in that. But anything above the presentation layer is being shared. Um, so let's look at a case study at Google on how Kotlin multi-platform evolved from 2020 to 2025. So in 2020, Google first started experimenting with this technology. They had the first preview. They had the first they had a first team looking at into this technology. By 2021, they were experimenting with Kotlin multi-platform in their workspace apps. So Gmail, all the workspace related apps, they were trying to experiment it on the back door. They were not releasing anything to production yet. They were just trying it internally. 2022, Google releases internally. They releases some dev libraries. This is only for internal use. They were not perfect. They were usable, but they were not perfect. There were issues. If you had experience in both technologies, you could navigate around them, but they were still, not cooked properly. 2023, they had an alpha release for these internal libraries. They continued supporting it. They continued adding more and more resources into the technology. And as you all know, in 2024, Google officially supports Kotlin multi-platform. Um, they have Kotlin multi-platform on their documentation page. On the Android documentation page, you can find the reference to Kotlin multi-platform. So they are very serious about it. And 2025, we are only in the first quarter of 2025, and we have all the famous Jetpack libraries, some of the famous Jetpack libraries which we all love, like paging, data store, and view models. Yes, view models is also available right now in Kotlin multi-platform. Room is in alpha, but it is promising it will it's gonna mature really soon, and we'll be able to use Room in our local KMP projects. Um, no, Room, when you implement Room on a KMP level, it will share data on iOS and Android. So all of these libraries are sharing logic on each platforms. View model even, so you can share a view model. So we'll come to that. I'll come to that part. But the idea is having one view, and the view model is shared between iOS and Android. So you're not even having, you don't even have to create like clone view models on each platform. You can and it gets all those magic by default. All the model magic which we love right now in Android development, we get all of that in KMP. Any more questions? All right. So what is shared? So you had a question? No? Okay. So what is shared? We share the business logic, uh, the brain of the application. Let's say you are a bank and you have very complex calculation of deciding the interest rate, or what happens to this interest rate, what happens when I have this much balance, this much interest rate, what is my projected value. You have complicated logics. You are Uber Eats, you get lot of annotations as a response, and you have a native algorithm which will filter, or which will sort these annotations in a certain way. This is the brain of your product that is shared. uh, Networking calls are shared. All the request response, we have a very famous ktor library, mature enough to be used, is being used in production. All of that, your request response, your error handling, uh, your data models, your DTOs, handling different responses in different ways, modeling your data in different ways, all of that can be shared. The local database I just talked about can be shared. Uh, we uh, we have a SQL database. You can have a SQL database, can build an offline first app by just sharing everything about the database, um, between iOS and Android. Analytics. I think this is the best use case of Kotlin Multiplatform. If any one of you has worked in a scaled product and if has tried to implement analytics, you would realize how important it is to have consistent implementation of analytics across Android and iOS. If one platform does something differently, the matrix in the end will change. So it's really crucial to have to share analytics. Logging. If you are logging to Dynatrace, you're logging to Datadog. Anything of that, you are logging how the user behaves in the app. You're sharing that, and you're sharing the domain layer. You're sharing the innermost layer of your application. You're sharing the brain of your application on how your app really works, irrespective of the response. What are data, what are the models, what is the heart of your application. That piece is shared so that you can unit test it. All of this can be unit tested, and when you unit test, you do it on one platform, and you just get it for free for other one, which also means, which is very important to think, that you solve bugs on one platform and it automatically impacts the other platform. But which also means that if there's bug on one platform, there's a bug in another platform. But so that's a trade-off. But sure, I mean, all of us don't want bugs. So what is not shared? So in an iOS project, Swift UI or view controller logic will not be shared. To answer your question, the view models will be shared. Again, as in the example, the view models are sitting in KMP package, and they will be shared across iOS and Android. On Android, similar thing. The view layer, the Jetpack Compose, the XML, that is not shared. Everything else is shared. Which brings me to some of the common open source libraries used to do whatever I've talked about so far. So if you want to do networking in a KMP project, the de facto solution you would go for is ktor. It's better than retrofit, I would say. It's easier to use than retrofit. It's more intuitive. But if you're trying to do a GraphQL sort of app, you can so Apollo has their Kotlin multi-platform implementation, so you can build a GraphQL app on this technology. For databases, we have SQLite, Realm, and Datastore. Realm is again a no SQL database that is available on this technology. SQLite is available, and again, Room is in alpha, so that will be also be supported very soon. For DI, unfortunately, Hilt is not there yet. Dagger is not there yet. We hope we get it, but until then, We have Coin. Coin is a really good DI framework. It is compile time. That is a little uh, downside, but other than that, it's a great library to work with. It's a great library to reason about. Very similar to how Hilt works, but it's a great library, and it'll work in with all the DI needs of a KMP project. For analytics, we can use Napier. So Napier is equivalent to Timber on Android. You can log stuff, you can log to external resource, all that good stuff. And when you log from one, it logs in the both platforms. We have some utility libraries. You can do date and time library, which really implements the date and time functionality across each platform. Moco is another one. Sky, our friend here really talked about this library. I will go over this library in much more detail later down in my slides, but we have Sky. And for testing, we have Kotlin test and Mokavit. I've never used that one, but yeah. So what are the current limitations of this technology? Obviously, grass is always greener on the other side. Kotlin Multiplatform is no different. It has its own problems. First and the foremost is the Swift and Objective-C interoperability. So Kotlin compiles down to Objective-C. However, most iOS developers don't want that. They want Swift because Swift has good language features which Objective-C doesn't have. So that's a very big limitation. A practical limitation, even still, you need two IDEs to make a cross-platform app. You need Xcode and you need Android Studio. There was another IDE. There is another IDE called Fleet. It's again by JetBrains. It's not very well. It's good to work with, but still, being a native developer, I would still prefer to work with with Android Studio or Xcode. So which automatically means debugging, especially on iOS, is tricky because you cannot put a breakpoint from an iOS code. So you have to really log and see what the response you got and how to solve it. If you're running an iOS app, you cannot put a breakpoint on the Kotlin side of it. Firebase SDK is missing. So we all know how important Firebase is for our mobile applications, and we don't have an official support from Firebase yet. I hope we get it soon. They do have a mention about this on their documentation page, but we don't really have an official thing to use yet. The build process is pretty complicated for a KMP project. If you have a CI/CD setup, it's fairly complicated to incorporate KMP into that CI/CD pipeline because now with running one application executes two different executables, and then you have to manage that somehow. The project structure is I would say pretty complex. It's really it gets easier once we get a hang of it, but the initial project structure which we open on Android Studio is pretty complicated, and it takes some time to get used to that product structure. It gets some time to get used to where things are. Where are we looking for? Are you looking for in a shared folder? Are you looking in the Android specific folder? If you're looking in iOS, you will be mostly doing it on Xcode. But the structure of the project is not rightly, like, it's not obvious as an Android app. Now, because both platform have different implementation of memory management, there are problems. There can be problems regarding to this. One uses ARC, the other one uses garbage collector. So we don't have the implementation of weak reference from ARC. If you know what that is from ARC, we don't have that. on this side of things. So we may end up in a situation where we are leaking some resources, and we'll have to build for that. You'll have to really build, keeping that you're not holding on to expensive resources in your shared part of the code. Um, Even though it's not a new technology to learn for Android engineers, for iOS engineers, it's a huge learning curve. They'll have to technically learn a new stack altogether. Uh, so for Android engineers, it's not that much true. There's only few concepts. There's a concept of expect and actual, which is glorified interfaces. Not exactly, but something similar. Um, but So that's the only concept for an Android engineer. But for an iOS engineer, it's relative a lot of work to get and up to speed with this technology. And then there's the biggest limitation I feel is the threading model difference. Android uses coroutines. Uh, iOS doesn't have a coroutine equivalent. So we have a problem. On iOS wants to spin up multiple threads, but coroutine will not spin up multiple threads. It will have multiple suspend functions running in the same thread, maybe sharing the same thread, maybe spinning up a new thread. But we don't have an one-to-one mapping of how threading works on each platform, which is a problem, because if you want to listen to a flow from a iOS app, there are ways to do it. There are lots and lots of ways to do it, but the de facto way is you have a completion block, uh, which really kills the all the the goodness we got from suspend functions in the first place. It's not so it's not, well, it's not behaving as it should behave. It's not actually suspending. You have a completion block now. So that's the biggest problem. Um, Speaking of problems, we have one possible solution from TouchLab, Sky again. Shout out to them. This is an open source project um, which aims to streamline some of these challenges. Um, so they so the good part about Sky is they generate Swift friendly. So they convert Kotlin into friendly Swift. Uh, they convert it into Swift instead of Objective C. Well, they're still doing some mapping from Objective C to Swift behind the scenes, but the developer in the end is working with Swift and Kotlin, so which is a huge plus. Um, so they so Kotlin enums are reference types. iOS enums are value types. One is password reference. Other one is creating a new copy every time. So they don't really map to each other. But if we enable Sky in our project, you can do that. Same with sealed classes. We don't have a concept of sealed class on iOS. If for iOS engineers, sealed classes, imagine having a switch statement over a class, like having as is and having a switch statement over it. That's a sealed class, and we don't really have a concept similar on Swift. But so that what that means is, if you have a sealed class in your shared code, you cannot use it in a native code. But with Sky, yes, for sure, you can do that. Default arguments is a good one. um, when you define a function, you don't want to pass every variable every time. You will have few parameters which will be default by nature. um, in the de facto world, that's not supported, but with Sky, yeah, you can do it. um, the biggest plus is the flows are converted into async sequence, and suspend functions are converted into async functions, which is cool because you can get the similar behavior on each platform. They both are similar concepts, even though they work differently behind the scenes, they are similar concepts on each platform. And by this, using this library will enable using these. And the, again, to speak, the package, so the code which is generated is directly imported as a framework in Xcode. uh, so if you know iOS development, you know they are Xcode imports frameworks. If you use CocoaPods, you I think they import a framework, so that the code is generated is directly imported into an iOS project. Uh, Speaking of which, we are on to the roadmap of what is next in this journey. So JetBrains is supporting them. It has is doubling down on its support for this technology. Um, the first thing they promised to do this year is they are improving the tooling for a Kotlin multi-platform app development. So they want, so so I talked about an IDE called Fleet in earlier. JetBrains has promised that Kotlin multi-platform development will be possible right from Android Studio. You don't have to switch IDEs uh, once it is done. But that's the idea. Everything will happen inside Android Studio, and they're working really closely with Google to enable that. Um, Kotlin to Swift export. So instead of exporting to Objective C, they want to export to Swift now, which is great because now you get all other, like you have only one level of API to work with. Um, Great for the great developer experience, will really improve how developers build apps on these technologies. They are increasing they are increasing their support for library ecosystem. Um, so if you're building a library on Kotlin multi-platform, they are increasing the support. One of the biggest use case of Kotlin multi-platform is to build a library, and their JetBrains is promoting it. They are adding more resources into it to make that process more streamlined of building a library, of publishing a library, of having different artifacts for each platform. Ampere, this is a build tool. This was an experimental build tool from JetBrains. Uh, they plan to make it stable so that the CI/CD pipeline process for a KMP project can be simplified. And yeah, this will really help on the adoption, because right now CI/CD is a problem. Um Now in 2025, Google is supporting this technology. They officially support it. They never did it for Flutter. With means more support for Jetpack libraries. Who knows? One day we will have our own work manager, which can run background operations on each platform. And the biggest piece is Compose multi-platform. Um, well, that's a topic for a new talk. But what essentially that means is you can share the UI between iOS and Android too, while having all the advantages we just talked about. So that is coming soon. That it's still in beta, I think, or alpha, but it's ready to go stable this year, or that's what they are promising. So really looking forward to that. Who is using KMP in production right now? This is one of the screenshots from JetBrains website. I'm sure there are much more companies out there, but these are some of the big names: Cash App, Philips, VMware, Meetup, Quizlet, Netflix, TouchLab, and that's about it. Running on, okay, we could on time. After this, I have prepared a small demo which I want to go over. It is nothing fancy. It's a small project where we will make API call. We'll get the response, and we'll display it on each platform. So the source code is available on my GitHub. Here's the GitHub if you want to check it out.